All right, why don't we get rolling? Well, welcome to the Energy Solutions Professional Services webinar series. Presentation today is on commercial industrial utility rate optimization. And the objective is to provide, I guess, some additional value to customers or your customers around, how to leverage different strategies, including energy storage, but also energy efficiency and optimization, which we'll get into, to improve your value to customers. And so that's really our objective. Your presenters today are myself. I'm Darcy Otis. I'm the Vice President of Operations for Energy Solutions and Supplies. We have with us today Russell Williams from Renon Power. He's Director of Customer Empowerment. And Jose Arias from Solis, who's an Applications Engineer.
The slide deck is not being shown.
The slide's not being shown. Let's share it then. There we go. Is that better?
Yeah.
Perfect. Thank you. Talk a little bit about a quick agenda here. So we'll spend a little bit of time just talking about commercial and industrial rate structures in the US at a high level. And we'll talk a little bit about what we call, in the second item, is the holistic approach to energy efficiency and saving energy for customers. That can be efficiency optimization, as I mentioned before, as well as talking a little bit about negotiating a new rate structure, or what are the things that go into looking at different rate structures. And then my colleagues are going to talk a little bit about some applications and case studies around the practical application of energy storage as a potential measure or technology to help with some of these measures. So commercial and industrial rate structures in the US typically have four main different categories for rate structure. There's typically a fixed charge, a flat charge on the rate. There's usually some sort of an energy consumption charge or an energy charge, kilowatt hour based typically, or could be kVA hour. There's demand charges. And there's also on large industrial rates often power factor charge as well, or an efficiency charge. And I'll get into each one of these a little more detail. So fixed charges typically could be anywhere from a customer service charge, just a flat service or a fee for the service. Could be distribution and delivery charges, depending on the market and utility. Could be an infrastructure fee. Maybe there's certain infrastructure that's paid for by the utility to support a particular site, or an upgrade in infrastructure that the utility is charging back for. Or there could be additional surcharges and riders as well, which could be mandated from the government side, et cetera, from that perspective. So those are typically the fixed charges and rates. From my perspective, we want to see the fixed charges as low as possible, so we have more flexibility in some of the other charges within the rate structure itself. The most common charge people are familiar with are consumption charges. Usually they're energy based, so kilowatt hour is the most common. They can be time of use based, so when you use that energy, and that usually is dependent on when the utilities costs are the highest, or when the highest demand is there. They can be a tiered structure, or they can be kind of a version of time of use, which is on peak, off peak type of rate structure. So you can see on the left just a quick example of a time of use where it's higher, first thing in the morning and higher in the evening. Probably more a residential rate than necessarily a commercial one or industrial one. A lot of times industrial users are during the day versus the evening, or time of year is a very common one. Higher structures in the summer versus structures in the wintertime from a production standpoint. The other key component, typically a large component to a commercial industrial rate structure, is demand. And demand is essentially a power charge. It's meant from a utility standpoint to recover dollars that are spent for infrastructure to support a particular customer, i.e. wires, transformers, the service, and that type of thing. And it usually is some dollar amount per kilowatt used within some time period. It's often called a capacity charge because essentially they're going to provide a certain amount of capacity for your worst case or for a customer's worst case. It's usually measured in a 15-minute or 30-minute interval. So it's the maximum power consumed within an interval. And oftentimes then it's multiplied by some sort of factor or a dollar figure per kilowatt. And that could be a daily charge. Hey, it's so much per your maximum kilowatt a day. That could be some other time period, a monthly or within a billing period. Or it could be a scenario that's sometimes called a ratchet. That's the third item here, where it could be your worst case within a longer time period, like it could be up to a year. So your worst case, you're paying a minimum fee of your ratchet or where it's got to the highest, or a percentage of that over the longest term time frame. So an example, and I've seen rates where in the summer, you hit your peak and you pay 80% of that peak times your demand charge as a minimum on your bill for the rest of the year. So which is a pretty heavy penalty for having that highest service available at your site. The final factor that's often on a commercial and industrial rate is called power factor. I'll try and keep this real simple, but basically what happens is your current and your voltage become out of phase within your facility. How does that happen? Typically, it happens if you have an inductive load or a capacitive load. Most often, it's an inductive load, like an electrical motor or that type of thing that induces current, which essentially gets the current and the voltage out of phase. That first picture that's on my right, or the right side of the screen, the one on the left. And so essentially it impacts the actual power being used or available within the facility. And so without getting too complicated into the actual formula of it, since your voltage and current are out of phase, then at any given time, the actual apparent or actual power is less than what it could be, the apparent power, and therefore there's an efficiency there that's not as efficient as it could be in using power within the facility. Is kind of the simplest way. They factor that efficiency in to an ideal power factor on a particular bill. And I gave an example here. For example, if you measured, hey, I had 1,000 kilowatt peak and I had a power factor of 0.8, so I'm 0.8% efficient or 80% efficient, and the utility's target power factor is 0.95, then I'm going to get billed the difference, or my peak is going to get factored on that ratio to give me a higher peak demand, basically, charge for whatever that peak demand charge is for that month. So you can see that can be significant boost up to 10 to 20% or even more additional cost on the demand side of your power bill, which on large industrial rates can make up a majority of your bill. So those are kind of how the different factors of a current rate structure in the US. So what do you do about it? Well, there's a number of things you can do. You can look at, starting on the right side, you can look at the efficiency side of that. So you can look at, how do I become more efficient? What's in using energy? And we'll talk more in detail about that. You can optimize the use of energy. So maybe you're using less, but you're using more optimally. And you can change or look at how do you do a different rate structure, and there's multiple rate structures available from utilities. So if you do the right two things, does that get you in a different rate structure? And of course, it's always a value versus cost scenario where you're trying to do an iterative approach to how do we overall reduce the utility bill. So if we talk about efficiency, here are some examples of efficiency. Upgrade lighting, been significant improvements in lighting technology. We're at LED technology now, which is significantly more efficient than it used to be. There's still a lot of older technology that's out there, and usually there's a pretty quick payback. And you say, well, that impacts both your demand as well as your consumption, and potentially even power factor costs on components of the bill, because older technology uses magnetic ballasts or ballasts, which is an inductive load and can be large in a large facility. You can upgrade HVAC systems. Is much more efficient than technology that was put in 10, 20 years ago. So again, reducing your overall load and certainly reducing your peak. You can upgrade motors, more efficient motors. You can add in occupancy sensors, time clocks. You can do temperature setback. Sometimes temperature setback doesn't get a lot of publicity. It always gets talked about, but I don't know if anyone really understands the impact. The heat transfer is directly proportional to the temperature difference between inside and outside. And so if you can reduce that difference by 10%, then you're reducing your HVAC costs by 10%. So that can be significant. And obviously there's always a comfort component to it, but that can be significant. You can also optimize energy. And this is where energy storage kind of comes into play, is you can shift loads. Okay, I'm back, I think.
Yes.
Okay, wow, that was sudden. I promise I didn't hear anything. Okay. So where were we? We're talking about optimization. And we talked a little bit about this is where energy storage comes into play. So we can load shift. What's load shift? Well, if you have some loads that don't have to run during your peak time of use charges for usage charge, or when you're setting your peak, then that's the best time. Then if you can load, shift those to non-peak times.
Darcy, can you share the slide presentation, please? Thank you.
Oh,
We got a
there we go. Got
couple
it.
commentators.
Thank you. There we go again. Had to restart everything. Okay, so that's the load shifting piece of it. Is being able to move loads, to off peak times, so you don't set a peak demand, and or you're at time of use charges that are less during the day. You can peak shave, so that's essentially shutting down loads that aren't as critical to save your peak demand charges. You could do one of the bigger items that we've seen with customers is you can go to a more of a demand ventilation scenario. So you have to say, hey, we're talking electrical things here, but what about one of the biggest costs is over ventilating in buildings. It's bringing in more outdoor air than you need to in buildings that are designed or at an occupancy that's significantly less than design. And so there's things that can be done to reduce your energy consumption and peak as well from a demand from that perspective. You can do power factor correction. So we talked a little bit about power factor. If you have inductive loads, then you can use capacitors to either at the entrance or at the actual load itself, so a motor, for example, and improve your power factor. You can use alternate energy, something we're all familiar with. You can use solar, you can use wind, You can use a combination of solar and energy storage. So that gives you, for example, capacity during the day to offset a peak in solar, but then you use energy storage to carry you through sort of the major HVAC load if you're in a commercial building, or an industrial building, maybe it's over a certain usage of major consuming equipment. And then, of course, we talked about energy storage. You can use the energy storage systems technology with or without alternate energy to allow you to load shift. So essentially, hey, let's take some load off during peak times, or it allows you to peak shave. So then you can use that energy storage rather than the grid when you're at a point where you're setting a peak, which can save a significant amount from an optimization standpoint. Let's talk a little bit about rate structures. Some of the things that come into play here is that typically there's more than one commercial and industrial rate structure. Of course, there's more flexibility in a deregulated market than a regulated market, and more choices. But usually there's incentives, especially on peak shaving and that type of thing in different rate structures. It's going to be dependent on your energy and demand usage, which is kind of why on the previous slides we talked about, well, what do you do? How can you improve efficiency and optimization? So you can look at measures that do those things, like energy storage systems, and what the cost is against what rate structure that might put you into, or what rate structure that might allow you to negotiate. And of course, some are dependent on alternate energy and whether you want to sell that energy back to the grid, which has become less and less of a factor in current rate structures, because typically you're getting paid less and less if you sell it back. Another successful one in large industrial is curtailment. A lot of times you have backup generation. You have the ability to add a larger energy storage system or a combination hybrid generation plant that can help you curtail. And often utilities give significant incentives if you can curtail larger loads during their peaks in summer months. And curtailment, for those that don't know, basically means allowing the utility to shut down and or reduce your loads, or allowing you, or basically telling you to do that so you can curtail, and they'll give you a special rate structure if you can curtail. So that's what that is. Okay. Now let's turn things over to our experts here and talk a little bit about some different applications and case studies scenarios. First, Russell's going to talk a little bit about some, I guess, a case study on your end. So, you set, Russell?
Yeah, absolutely. Thanks, Darcy. I appreciate the lead in here, and he gave a lot of good context to what we're about to talk about in terms of how we see energy storage impact the bottom line when it comes to generating savings, and sometimes even producing revenue. So, just a quick little intro. I'm with Renon Power, and we'll talk a little bit more about the company after a quick overview of this case study here. So to pick up where Darcy had left off regarding some of the energy optimization strategies, we're going to be looking at how that can be impacted specifically from the energy storage perspective. So there's a few application scenarios that drive different revenue models. I want to move to the next slide here. So as was mentioned, you have kind of your standard expectations around peak shaving. So depending on your rate structure with the utility, a lot of the time when you're charged by that peak demand cost, that can often be 30%, like 20 to 30% of your total power bill, if not more. That can be very directly impacted by providing energy storage that is distributed and pulled from when you're at that peak demand range. So once you hit a particular threshold, the energy storage will dissipate and discharge in order to generate, to reduce the total peak that you're drawing from the grid. This is a very direct energy cost saving structure. There's also some applications where you'll see shifted cost between high demand and low demand time for cost of energy. For example, overnight 1 a.m. to 5 a.m. might be 17 cents kilowatt hour, whereas from 5 p.m. to 9 p.m. it's something like 35 cents a kilowatt hour. So in that peak shaving mode, there's also an opportunity for pure energy arbitrage. So this can be achieved even without a PV system. So a lot of the time there's value in having a PV system that will charge your batteries and allow you to dissipate when energy is needed, or you can leverage it for without solar, just for pure energy arbitrage in order to make it generate value from the difference in cost of energy when you sell back to the grid or when you store it for your own personal use. Another approach is kind of the EV charging model. So a lot of the time, new facilities that are installing EV chargers in order to kind of connect with the community a little bit more and provide value to their customer base will install high speed or DC fast chargers. The thing with fast charging is that it is a very rapid and intense kilowatt draw. So you're seeing a very high spike, and often this is creating a demand charge that's 2 or 3 times higher than those facilities had seen previously. As a result of that, you're getting massive spikes in cost, even though someone might only use the charger for 10 minutes that day. To mitigate this, you can use energy storage. It'll do a slow and continuous draw of energy, never driving up your total peak. You can actually have it tied into CTs that monitor what the total peak has been thus far this billing cycle, and then make sure to only ever charge the batteries when you are below a particular threshold of safety away from your current peak within that cycle. So a lot of really cool advantages that you can kind of create from this approach. Obviously, with energy storage, backup and resilience is a major use case. When the power goes out, it's nice for the lights to stay on. It's wild how energy dependent we are as an infrastructure these days. So you really quickly notice just how much everything becomes inoperable and life comes to a screeching halt when power is lost. So this is really, really critical for manufacturing facilities. If they have even a slight amount of downtime, everything that's in production on the line can be lost. So a really high impact if energy is lost in some circumstances. And then finally, there's actually the revenue generation model. So participating in VPP programs. So that's virtual power plant models in which the utility can ask for a discharge of energy in order to help support demand from the grid. And those are circumstances where the utility will be paying a premium in order to secure additional energy. So that's a mechanism for transitioning from simply cost savings and energy cost reduction and resilience to actual revenue generation in a really cool way. So let's take a look at a particular scenario. We're just going to kind of use a hypothetical overview of an off-grid application here. If we move to the next slide. So one example is potential total off-grid applications. So whether there is somewhere like Puerto Rico where there is very fragile grid infrastructure, where there is grid, but it tends to go down 2 or 3 times a week with catastrophic outages at least once a month, or somewhere completely off grid, like Fiji, for example, where you'll have some very high-end hotels, resorts, and facilities. And then in addition, some of those more remote locations that are leveraged for their low cost in terms of manufacturing facilities. But as a result, there's that instability from the grid that makes it really hard and high risk to operate in those circumstances. So what you'll often see in these circumstances and what creates a really good savings and generation opportunity is leveraging a solar field with some energy storage rather than just putting PV on site. PV will generate some power in that it can offset your consumption during the day and give you more stability during the day. However, that's limited to when the sun's in the sky. So to really leverage your advantage, it makes a ton of sense to add energy storage. So the revenue logic here is that batteries can serve as kind of the stabilizing backup power that works with existing photovoltaic systems or DC generators and really smooths the switching between on-grid and off-grid applications. And that was the next slide there already, sorry. I jumped ahead of myself here a little bit. So as I mentioned, there's a lot of different approaches to this. And then if we look at the last slide in regards to this particular use case, what the revenue composition looks like in terms of how you can generate higher rates of return when you choose to include energy storage rather than just a solar system. So as I mentioned, if there is a loss of power or voltage sags, it can cause massive damage to equipment, loss of production on the line, really critical infrastructure or critical manufacturing processes like chip manufacturing, or where human safety regarding like hospitals. If you have a blip in surgery, that could create massive issues for people. Um, it also reduces diesel costs. So one thing you'll notice if you've ever traveled to Puerto Rico is that you might be driving down the street and the street lights are off, but all the buildings around you are still lit. And the reason for that is there is a very robust diesel infrastructure. Pretty much every single, I wouldn't necessarily call it infrastructure, but every individual facility has their own diesel generator that's running in order to keep the lights on. There's incredibly high costs with A, constant consumption of diesel energy, B, the ongoing usage and maintenance of that equipment, and it is a limited threshold in terms of having the amount of diesel power that you can, and there's additional fuel maintenance and just ongoing operation costs there. And that doesn't necessarily, it mitigates the risk and provides backup, but it doesn't necessarily provide any benefit in terms of cost savings or energy infrastructure. And then obviously there's a safety component of being able to have power. A lot of the time when you're looking at solar returns, you're looking at roughly a 10-year threshold just by having the solar producing energy during the day to offset some of your energy costs during the day. And this works well for some manufacturing facilities where they do have their highest peak consumption during the day. But a lot of the time places are running 3 shifts. So you'll see just, and granted it's cheaper energy overnight, but the peak demands will still show up even if it's an off hours time. So by having these energy storage solutions that can oversize PV systems now, that'll provide power during the day, as well as charge the batteries so that you actually get additional deployment at night. And this can increase the rate of return by 12 to 16%, making your payback period drop from 10 years to the 5 to 7 year window. And that's a really massive impact on the value of doing these projects as a whole. And I'll talk a little bit more about how we're highlighting that as a company as we move forward here. But what makes all this possible is the actual energy storage equipment. So I want to quickly talk about one of our products that we actually are launching in combination with Solis, and this is going to be our MPAC 261AS. So it's a 261 kilowatt hour energy storage system, and it's paired with a Solis 125 inverter, hybrid inverter. I'm very excited to announce this partnership. The 125 kilowatt inverter, as Jose will share, is coming down the pipeline in a few months this year. I'm thinking late summer is what we're expecting. But it gives a lot of flexibility at this larger utility scale. You can actually couple the batteries with this inverter in an AC or DC parallel mechanism. So if you need as much power as possible, you can do one inverter per MPAC to drive so that every battery pack gets you an additional 125 kilowatts of power. This is the solution you're going to want to take when you're really trying to offset that peak demand charge that can really outsize that portion of your bill. So if you just need to offset short-term high power output, the more inverters, the better. Whereas some people are looking much more for the resiliency, their total threshold for power consumption isn't as high. Maybe it's only 100 kilowatts, but they want to be able to last without power, without support from the grid for days at a time. If it's a cloudy week, they want to still be able to make sure the lights stay on without having to fire up their diesel generators. And what that means is that you can run multiple of these DC block batteries with a single inverter. So those are kind of the two use case mechanisms that you see across the bottom here. There's a lot of additional advantages that the Solis inverter brings to the table. Not only is it going to be fully UL certified, but its ability to do changeover, its switching rate is going to be incredibly quick, which makes really good for smooth manufacturing process for on-off grid switching and backup resilience. And then it also allows you to tie in solar into the inverter in combination with the generators, while the Solis will do all of the kind of brains of the operation in terms of management and energy consumption. I'll hand it off to Jose here in a moment to talk more about that in detail, as he is far more the expert on it than I am. But I wanted to really quickly, before saying goodbye, talk about our Renon as a whole as a company here. So we're an energy storage focused company. Everything we do is around the battery side of things and the energy storage side. We have been in business since roughly 2014 and have recently really grown our US brand, and we're actually opening up a manufacturing facility in McKinney, Texas. So we have the facility, we have the manufacturing equipment. We're just in the process of doing the final installation of getting the manufacturing equipment up and running. That's going to be very useful for both residential and commercial development. And as a result, we're going to be building more FIAT compliant and BABA compliant batteries, which is essential for the changing legislative requirements of 2026. So very excited about all those things. One thing I wanted to jump back to that we mentioned in terms of creating ongoing value for our customers and really improving that ROI. One campaign that we are launching this year is that for any projects we deliver, as a part of that project timeline, we're not handing off the project just when we get to commissioning. So we'll support commissioning processes, obviously all the pre-designed work, the commissioning process, but then actually once a project is commissioned, we're looking to follow up on a 30, 60, and 90-day timescale. Once a project is up and running to at the 30-day mark, ensure the installation went smoothly. At the 60-day mark, validate that operations are as expected and they're able to utilize it in the expected use case. And then C3, at the 90-day mark, do an actual value assessment to make sure that these batteries are creating value, reducing the cost of their bills, and we can provide evidence that the value creation is there. So really looking to provide a complete white glove service for all of our customers, leveraging our larger scale C&I solutions. So if you'd like to find out more, we always host our own webinars on a probably 2 a month basis, sometimes 3 when we do it with partners as we are here. But with that, I will hand it off to Jose to dig in a little bit more on the Solis inverter and some of the incredible products that Solis brings to the table here, making inversion and cleaner energy possible.
Thank you, Russell. Okay, regarding, efficiency is about having control. And for that, we need to, for example, one application scenario is peak shaving. Usually peak shaving can be used alone or depending on the battery bank capacity, it can be also used together with load shifting. In this case, how it works, Solis will be continually or actively monitoring the utility meter. And when a specific limit is defined, in this example is 200 kilowatt, the inverter will be checking this limit. And when the limit is planned to be exceeded, because, for example, air conditioner, motors, or whatever huge loads are turned on, the inverter will be discharging the battery in order to avoid all these peaks loads to be incrementing the electrical bill that you will be having, because as mentioned before, the impact is in some cases is 20, 30, or some literature even specifies 50% increment in the electrical bill because of the peak demand that is being presented for some specific applications. So the result of having this control is that you can avoid all these peak demand charges, or also in combination with load shifting, it will be reducing drastically the electrical bill that you will be having. And this will make your business, the specific application, more efficient, reducing costs and making more feasible to develop projects. It can be started small, maybe without PV at the beginning, and later on in a later stage, added a PV array connected to the PV hybrid inverter from Solis. And this as a combination will be providing or giving you great results regarding the economic feasibility of this investment. It can be charging from the grid when it's a cheap electricity cost, and discharging when it makes more sense when you don't have PV at the beginning. So it all depends on the budget and the timeline, but also, whatever is specific, some jurisdictions, some utilities, they have a specific rate structure that it makes more sense to start smaller and later on going bigger in battery bank capacity, and also adding a PV array. Next slide, please. This is one example regarding recovering the capital expenditure at the beginning. In this specific project, we are talking about an investment of $150,000, and you have some incentives like the 30% federal investment tax credit, and also you have depreciation that you can get for this in in the first year. And you can see that from this specific slide, you are paying for the system roughly half the cost. In some other specific scenarios, you will be paying 2 tiers of the cost only, but it's still a good business. And more than other thing, it provides you reliability, control over your expenses, and also it provides you energy security, because when you have this backup, either having PV array, generator, or batteries, the more complex you make the system, the more reliable, the more resilient it is for your specific needs. And at the end, it's not only about this, it's at the end, it makes a financial sense when the business department analyze this project, if it's a good idea to invest. They can see the numbers that they match correctly, or they are attractive. And when they see the metrics, they say, okay, we can go and try and check how we can do it in different stages, whatever makes more sense at this specific time frame. We can start like that and later on expand on this. Continue. Next slide, please. And regarding the working together with Renon, we have different solutions from Solis. We have 30, 40, 50, and 60 models already available, hybrid inverters at 480 volts AC, 3-phase, and also we have 208. And the solution that we already are offering in the market is together with the solution from Renon, named eCube 60 AP. And you can see that it's a lithium iron phosphate cabinet, high voltage, because it's commercial. And the starting size of the battery bank is 61 kilowatt hours, and you can scale up to 360 kilowatt hours. And you can parallel inverters if needed, also for adding instant power, surge power capabilities, not only energy storage, either 2 hours, 3 hours, 4 hours backup time frame, but also you can parallel up to 10 inverters, and every inverter having his own battery bank. And regarding specific requirements for utilities, in some jurisdictions, especially the most strict ones in the US, like California, New York, Massachusetts, we are listed together with Renon as UL 9540 Edition 3 compliant. That is the newest and the most strict one in the industry. And it also provides you like as an added value that the insurance cost is lower, instead of having a edition 2 or edition 1 solution deployed, that will be increasing the cost of the insurance. So this solution, it is already available, and we are also planning to release around middle of the year bigger PV hybrid inverters that will be working together with Renon. We are going to be having 100, 125, 150s, and those are going to be also paired together with the solution that Renon is offering to the market. Next slide, please. And regarding Solis, we are the third largest in the world. We were founded in 2005. We have been present in the US since 2009. And we have presence globally in around 100 countries. Global ranked third place regarding global shipments. And we have the widest or the most robust portfolio offering in the industry of string inverters, not only grid-tied, but also now hybrid inverters for energy storage applications. And when you pair a good inverter, string inverter, with a good battery manufacturer like Renon, you get warranties that you will be getting a good solution, not only technically, but also price point competitive. And it will be providing very good metrics when you do the financial analysis. That's mostly about Solis. Thank you. Darcy, I think you are next.
Yes, I am. Well, why don't we wrap this up here? Let's Next, let me just check here. Want to talk a little bit about energy solutions. For those that don't know, we're a nationwide solar and energy storage distributor. Represent a lot of top brands like the ones that we partnered with today and the folks we did today. We differentiate ourselves by providing additional services, logistics, professional services, recycle, reclaim, and reuse in our ESAS marketplace. And so those are the key things that we lead with long-term partnerships and a trusted advisor relationship with our customers. Let's go ahead and finish up here. And now it's time for any questions. If we have any, there's a Q&A function that's within Microsoft Teams, and we'll take any questions at this stage. All right, it's being pretty quiet.
One I might encourage here is, Jose, if you could share the specific inverter model that pairs with the 60 AP, you could just talk a little bit more, because I was able to mention the 261 we have coming down the line, but it's nice to know exactly what the pairing combination is of the Solis and Renon, where we currently stand. So with our E-Cube 61 kilowatt hour battery, currently pairs with the Solis 60. If you have the exact model number, that might be worth dropping in the chat just for people to reference.
Yeah, I'm putting that information on the chat, correct. And also the link. Is 30, 40, 50, and 60 hybrids, 3-phase. And also 30 kilowatt to 8. 5 models in total are available, correct.
Okay.
Awesome, thank you.
Thank you.
Sounds good. I'm just curious, in a general level, do we have anyone out there that is looking to try and differentiate themselves in the marketplace as the market's changing and are looking for support or interested in further webinars on this topic? Okay, I got a yes. If there aren't any specific questions, then I guess we'll go ahead and wrap everything up. Thank you for everyone attending today.
Thanks for the opportunity. There is one question about the warranty for the batteries.
Oh, okay. Russell, you want to grab that?
You are muted,
You're
Russell.
muted. Yeah.
Thank you, appreciate that. Saw it as soon as I started going. So for our the E-Cube, standard warranty is 10 years, 10 years, 8,000 cycles on the C&I products. So that would be the M-Pack and the Smart Matrix, was our megawatt solution, 1.67 megawatts. We didn't talk about here today, but on the larger solutions, it's 5 years standard with an extension up to 10. If you're in the if you're in the California region, for the M-Pack, it's the price in California is slightly higher because we just integrate that 10-year warranty. So as a result of being a part of the SCHIP program. So the California region, it's a standard 10-year, but it's just baked into the price. Most people extend up to the 10-year anyways, but 5 year is base, and you can extend it up to 15 total is needed. Yeah, and all of our residential stuff, it's 10 years, 8,000 cycles, as well as with the E-Cube.
Awesome. Thank you, Russell.
Yep.
Okay. Unless there's any other questions, we'll wrap things up.
Our EMS system does support VPP. It is something that is tied in with the inverter. So Jose, I can let you talk about that a little bit more.
Yeah, we are working with some integrators in order to support BPP. Yeah, we can check specific project details and analyze what we can offer for that, for sure.
Cool.
Okay, so that, there's another question, just sending the recording information, so we have that noted. Setting the presentation recording. If there's anyone else that would like that, just let us know. Okay. Am I gonna try the third time? We have more questions. Go ahead. We have time.
Yeah, well, you can also just hang out if anything comes up. So
Sure.
Yep. Oh, I've seen a bunch actually in the Q&A section. I don't know if we've addressed all of these.
Oh, there we go. Okay, we're getting a couple. Okay. So
I can answer. Just starting at the top of the list here.
Okay.
Actually, I guess we should start at the bottom of the list. Well, we might get through all of them. So how close do the actual storage savings come to the model projections? That kind of varies depending on how accurate the data that we have for previous uses. So if we're looking at like 3 months of your most recent power bills and we're modeling off of that in order to recreate what we expect your consumption to look like, it tends to be, I don't know, maybe plus or minus 15% in terms of actual posted savings. However, if we have more data, so for instance, the last 2 years, and we know what the projected utility rate changes, if there are any, if we have a better understanding of the industry, the location. Another major factor is what kind of incentives the local utilities might have, if you can get discounts on the battery. So all of those factors kind of pull in together to try and clarify what the entire cost portfolio, or what the cost portfolio is of the batteries, and then B, what the saving and impacts are. There's some nuance in terms of VPP participation, where if it's a new program that's getting up and running, we don't necessarily know how often they'll do demand calls or what the rates for those demand calls are fully defined. So I would say roughly plus or minus 15% on the less accurate side of things. So yeah, it's a 30% swing in either direction in terms of total range, which still feels reasonably accurate. So that's part of why we were looking to do, as I had mentioned, that kind of 90-day assessment to reevaluate how close was our projections to what the actual savings are. So that's something we pay pretty close attention to, and we're always working to improve our projections and our modeling.
Cool. I think there's a second one there, Russell, on just the what size?
Yeah, and what size BS? So just to read the question aloud, what size battery energy storage solutions are most being deployed by Renon? I will say Renon has a very wide suite of products. We have everything down to 5 kilowatt hours for residential to the megawatt hour scale, 5 megawatt plus. On the C&I side, we have 3 major products. We have that E-Cube at the 61 kilowatt hour mark. We have the M-Pack at that 261 kilowatt hour mark, and then the Smart Matrix at the 1.67 megawatt hour mark, or 1,670 kilowatt hours. And the reason for these kinds of different sizes is that you do see a wide nuance of ranges. There's some very large, kind of the 20 to 50 megawatt hour scale, people will tend to be a little bit more purely price focused, where you'll have kind of people that are coming in and doing longer term installations in which they'll buy the products, the cells show up separately, they have to have a installation team on site for a month in order to get the whole system up and running. We really focus on drop, plug and play solutions, and that's what's kind of given us a nice niche in the small to large commercial range. So right in that kind of medium window that has been a bit underserved traditionally in the last several years, of the hundreds of kilowatt hours, well, less than necessarily 5 megawatt hours. So that's part of the advantage of the 10 by 10 foot container is our Smart Matrix. It's a 1.67 solution that I mentioned. You can do 3 of those together to get that 5 megawatt hour scale very quickly, while maintaining it being fully shippable, fully assembled, which is part of why we did that 10 foot container. So a wide range of solutions. We're seeing a lot, I would say, of like 2 or 3 of the E cubes together, so roughly like the 100, 120 range. But very quickly, people are transitioning to the MPAC just because of that energy density. You don't need as much space. Still roughly the footprint of like a large pallet, maybe even a little smaller than that. And then you can do 2 or 3 of those together in a very efficient way to get half a megawatt of storage. And a lot of the time that meets needs of small to mid-scale residential. Some of the stuff we've done has even been like larger scale single phase solutions. So the scalability of our residential stuff is a major advantage, I would say, as well. Our stackable Extreme LV solution, that's a single phase battery, can go up to 40 kilowatt hours per stack, and you can do 31 of those stacks in parallel. So even in single phase solutions, or for some homeowners, for instance, in the Michigan area, there's a ton of rebates on batteries. So we're seeing people do 1 or 2 inverters with almost 9 of our Excellent Plus battery banks, each of those being 16 kilowatt hours. So people are doing 100 plus kilowatt hours on their single phase residential stuff. So really is nuanced to the use case, to the legislation of the area that you're installing.